Let's have a look at the process of elimination, and it's a different method from substitution, but it does the same job. So we're going to start with two equations, and we've seen equations like this before. Now, the purpose of elimination is to solve for x and y, but the nice thing about it is that we don't need to do any rearranging of equations like we did with substitution. But what is important is that when you have your two equations, you have your x's lined up and your y's lined up in a column downwards, and you have your numbers lined up downwards in a column. Now for substitution, it was essential that we had one lonely x or y. Even though we do have here for elimination, we'll see on the next page, we don't have to have a lonely x or y. So elimination is very handy when we can't find that lonely x or y. Now what we're going to do is we draw a line across underneath, and in this case I want to subtract. Sometimes I can add, sometimes we can subtract. In this case I'm going to choose to subtract, and that's because I want my x's to go away. So and I'm going to subtract every single thing in this column, but in a downwards fashion. So I'm going to do x minus x, that will give me no x, and then I'm going to do y minus a negative y, be careful there, that will give me a plus y, so I'll have 2y, and 12 minus 2 will give me 10. Now notice how simple that was, and from here you can almost see how to solve the rest of it. So notice here I said that we had to subtract. We could have also added, and if we added, then these two y's would have gone away, and we would have had 2x, but then we would have had 14, right? So it just depends. There's a bit of variety on what you might want to do. So let's do a swing underneath with the 2. So we get 10 divided by 2, and that gives us 5. Y equals 5. And now all we have to do, the second step is always the same as substitution. We're going to substitute that back into one of the original equations, and we'll choose 1 in this case. So here we go with the substituting in y, and that 5 goes over to the other side, and as we said, the x is 7, and we'll just write a solution like that, 7 comma 5, and then you can always check your solutions in the original equations. So let's try another example. Okay, this one also does have a lonely x or y, I notice here, so we could do substitution, but we're just going to stick with elimination. So in this case, I want to do something a little bit, just another step. And the reason for this step is because um, if I look downwards in my columns, I notice I have 2x and 3x. If I add and subtract those, they're not going to go away. I have 1y and negative 4y. If I add or subtract, they're not going to go away. So how do I make it so that I can eliminate either my x or my y? Well, if this y was a 4, so I'm choosing the easiest thing to do. If this was a 4, then I could make the y's go away. So that means I have to multiply every single thing in the first line by 4. So 2x times 4 is 8x, y times 4 is 4y, and 5 times 4 is 20. So I've just multiplied the whole first equation by 4. And now notice we're ready to go with addition or subtraction so that the y's can go away. Now think about what you would want to do, addition or subtraction. Hopefully you said addition, because a positive 4 and a plus a negative 4 is going to cancel each other out. So that's going to give us 0y. And we'll end up with, let's have a look. We'll end up with 11x. So 8x plus 3x will give us 11x. 20 plus 2 will give us 22. As we said, the y's canceled out. And we'll do a quick swing underneath with the 11, and 22 divided by 11 is 2. And we're almost there. So we'll quickly do the last step, which was 2, sub that into equation 1, um, and there's equation 1. We'll do our substitution, which is right there. So the x became a 2, and 2 times 2 is 4, and that went over to the other side. 5 minus 4 is 1, so we get y is 1. And we'll just write our solution properly like this.
On the
The
next
solution
page.
is 2 comma 1. And you can
Okay,
also
so here's
check
two
that
other
in
equations.
the
Now
original
here's really
equations.
where elimination would be absolutely necessary, because there is no lonely x or y, not in the first equation and not in the second. So we don't want to do any rearranging and substituting. We want to stick to elimination. What we also need to look for is, do I have any of the same equations, any of the same number of variables? So I have 2x and 3x. That doesn't work. I have 3y and 4y, so that doesn't work. So what am I going to do? Okay, I'm going to pick the x's because that has a 2 and a 3, which is a little bit smaller than the 3 and the 4. So if I multiply 2 by 3, I would get 6. And if I multiply 3 by 2, I would get 6. Then they would both be the same. So whatever I do to one variable, I have to do to the whole equation. So I'm going to multiply the top equation by 3 and the bottom equation by 2. So they look like this. Okay, and so each variable, each term here has been multiplied by 3. And then each of the bottom terms have been multiplied by 2. So we get these two. Okay, so now I can go ahead and subtract, because I want the 6's to go, or the x's to go away, and 6 minus 6 will be 0 x's, so that'll go away. Negative 9y minus positive 8y is negative 17y. Negative 39 minus 12 is negative 51. So you don't have to do any rearranging. Just keep everything where it is, and you can subtract or add that way. Now I can move the 51 over to the other side. It's positive. Divide it, negative 17 is going to swing underneath. 51 divided by negative 17 is negative 3. So I solved for y first this time. It doesn't matter if you solve for x or y first. And that just is going to go into one of our original equations. So we'll pick number 1, put the negative 3 in, there it is. Okay, and we'll do a little bit of bed math, multiply the 3's out, and positive 9 and negative 13 is negative 4, tidy that up. Take the 4 over to the other side, divide through by 2, and we get x is equal to 2. So we have our solution, which is 2 comma negative 3. Okay, let's just do one more for good measure. Now this is the challenge question, and this has brackets in it. So first of all, what do we have to do? We have to get it to look like this. So we're just going to tidy it up. We're going to multiply the 3 into the brackets here, the 4 into that bracket, the 3 in here. So we'll do some distributive property. Okay, so you can pause and look at that and just make sure it's all nice and tidied up. Okay, so multiplying out the brackets, we get this, and then we'll keep the x, then we'll put the y next, and it's nice to have all the numbers just after the equal sign on the right-hand side, okay? So a negative 3 and a negative 8 is negative 11, brought over to the other side, we get a positive 11 and a negative 5, and that will give us 6 over here. Let's do the same thing with the second equation, just tidy it up with the, get rid of the brackets, and then we'll put the 3x first, the negative y next, and then collect up all the constants, and they add to 0. That's okay. All right, so now we're going to subtract, and we're subtracting because remember that we want the x's will go away if we subtract, so 3 minus 3x is 0x, and then negative 4, be careful here, plus a negative y, minus a negative y is actually a plus y, so we'll be left with negative 3y, and 6 minus 0 is 6. We'll divide through by negative 3, and we get y equals negative 2. And then Our last step is just the same from there. We'll plug that into equation 1. Notice we're not picking equation 1 with all the brackets. I'm going to pick this nice tidied up equation 1, and we'll plug in the -2. There it is for y. So that's been substituted. Every time you substitute, put it in a bracket, and we'll multiply that out. -4 times -2 is +8. +8 goes to the other side to become a -8, and +6 gives us -2. We'll divide through by 3, and this time we end up with a fraction. And sometimes you do, so that's okay. We'll leave it like that. Don't change it to a decimal. So our solution is -2/3, comma, -2. And that's the process of elimination.